Hello, hello. Welcome to Generative AI Talk. My name is Victor. So let's first of all make some sound check that you can hear me. Please raise your hand if you can hear me. Amazing. So, I talk about generative AI already a couple months, and I heard some people said that if you work with generative AI for 1 month, you can count it as 1 year. So for today, I can say I already have, I know, like almost 20 years of experience in generative AI. And my talk today would be about multi-agents. But under the hood, we also will review MCP, strength agents, how to make the correct collaborations between your different generative AI agents. And before we jump into very complicated stuff, I mean like how exactly manage your multi-agent collaborations, let's start maybe from something simple. What's exactly generative AI and how it works? So, in the, like 2.5 years ago, when GPT appeared and the first models appeared, everyone started to test it. And what exactly model give us? It's predict the next token. It can answer to our question, just like, for example, what's the capital of Germany? So it's Berlin. But in reality, when we talk with model, we don't say, like, model does not understand our words. Model understands the tokens. And when we ask something about like what's the capital of Germany, we make the transitions from the words to the tokens. And based on the tokens, which is connected and related to each other in a vector store, we can predict what will be the future, what will be the next word, for example, or what will be the answer on our question. Models stay more smarter and smarter. And now, for example, you can send to the model almost like everything. It can be text, it can be audio, it can be some media, like, for example, images with vision. It's a good. But in general, when we talk with the model, every time when we ask something, it's something new. It's like we start from the scratch. And model does not know anything what we talked previously. For that reason, I believe you already saw that many of the applications in generative AI integrated, implemented history of conversation, append our previous context. And in that case, when we ask, for example, a couple questions, like, for example, what's the capital of Germany? The answer would be Berlin. What about Sweden? So as yesterday was Stockholm Summit, so it's Stockholm. And in reality, if we ask from the scratch the model, what's about Sweden, without giving the previous context, previous conversation, the answer would be Sweden is a nice country. So for that reason, in the area of generative AI, we added conversation. For that reason, mostly, I believe all of you already saw Converse API. We communicate with the model, this added additional previous context to give more information. The next step was related lack of our internal information. So you can think of the model on the way that it's model is a state of the whole internet in some point of time in the past. And our goal as people, as customers, as user, ask something, send a request using prompt engineering practice to get this information from the model. But still, model does not know anything about my internal information, my internal product, how we proceed, how we onboard new client, and so on. So for that reason, RAG, or Retrieval Augmented Generation, appeared on the market, and many companies started to upload the documents to RAG system. It's like vector store, and using a semantic search to find correlated context and enrich our initial request. And this brings us to agents in reality, because currently with additional tools, with additional functionality, for example, to communicate with external world, we can get any informations from our internal using the RAG, communicate to external API services and understand what currently happens, because one of them lack of capability of the model that models does not know anything about an external world. What's the weather today in Hamburg? So this is how looks like core stuff of our agents. Now I see also many implementations that in different frameworks we add the capability of memory. Memory, it means when we start new conversation, we store the previous, the history of our conversations, and now can start not from the scratch, again add additional context what's previously our customers, what's previously our users ask. Okay, that's what in general generative AI agents is. And now the question where to run it. So inside the AWS, we have amazing service, which is called Amazon Bedrock, where you have capability to select many different foundations models, starting from Amazon Nova and finishing Anthropic, Claude, Opus Sonnet. And just like 2 weeks ago, it was released, the first version, latest version. And also inside of the Bedrock, it's not only related to provide for you access to API. It's also give you opportunity to make some automations and create your own agent. And now also it exists capability to make like multi-agent collaborations when you create not one agent, but many of them. So what multi-agent collaborations can help us? So first of all, we can solve the problems that when one agent exists, it can be like a monolith. And it's can be very difficult to speed up development, to create a new functionality, and so on. But let's go a little bit deeper. What's exactly the problem and why we need multi-agents at all? So how usually happens when we create our first generative AI agents? So we started with maybe some super simple stuff, like for example, in my case, I want to create HR agent, and this HR agent will help me with, let's start from time off for our employers, so they will ask how many days I have and so on. For sure, next iteration, I want to extend the functionality. I want to give more capability of these agents, and what I add, let's add some additional information, just like our HR policy. Because maybe in some reason in your company, senior people plus 5 years of experience, they have more day offs per year and so on. Okay, that's good. Let's move on to the next step, the third version of our agents. And now we decided to add additional information related to leave of absence. Good, but it's not the final stop, and we decided, okay, let's extend and make the first version. For sure, when we talk about HR assistant, how about promotion? How I can grow, for example, today I'm senior, and tomorrow for sure I want to be a principal, and I want to understand what I should do in my company, in AWS, for example, and so on. And it leads us to the challenge that it's very complicated to support and add the functionality. And one of the reasons it's related to models in general, because agents can confuse. Model will have so many different contexts and doesn't understand what exactly user wants and how to route correctly your request. And what we can do in this situation? So exist a couple of the approaches. I think one of the easiest way, it would be just create a couple of the agents and make for them different logic, like different responsibility. Like for example, one agent will be responsible for time off, another agent will be responsible for leave of absence, and the third agent will be responsible for promotion. But how it looks like from user experience? If I want to ask something, how many days, for example, I left, what I should do to grow, and so on, I have to communicate with many different interfaces. It's not very good user experience from that perspective. And so, and still, when one agent can solve one problem, we have this silos of the configurations of the functionality, because one agent doesn't know anything about other functionality, for example, our HR policy. Or for example, we have to add HR policy to every agent. This is to bring us back to the slide what I show you how agents looks like. So we currently have, for example, 2 different agents. And what about if we just will create additional agent, what will be control our specialized agents, like supervisory agents or umbrella agents. You can call whatever you like. And that's exactly bring us to multi-collaborations of agents. And that is what you can do today in Bedrock, and it would be fully managed service for you. You even don't need to think how to deploy and so on. Your responsibility would be only related correctly to configure it, set up, and make the correct logic of your multi-agent collaboration. And now, with that, we have big opportunities. We have huge benefits of that. The first one, it would be unified user experience. So one entry point where we ask anything about our process, promotion, leave of absence, my vacation dates in this year, and so on. And also, even on that, we can automate more complicated, more complex tasks to have multi-steps collaborations between different agents. Let's start from unified experience. What exactly it means? So it will be one interface, and when our user, our customer, will ask, hey, how many days I have in 2025, for example, our supervisory agent would understand, based on the initial request, where to send this request. It's just like a routing. Understand, hey, sounds like based on the context, sounds like based on the current request, user wants to know about promotion, wants to know about leave of absence, wants to know about how many days he or she left in 2025, and send on the correct agents, which can proceed and return a more accurate result. So one interface almost for everything, with the right routing, and in that case, our supervisory agents, it would be our router. I would highly recommend to use a smaller model to make it faster. At the same time, enough smart to make this decision correct. And we can integrate many different, like functionality and growing as much as we need it. So just for example, today we have only like 3 agents under the hood. Maybe tomorrow we will need 80 agents or 20, doesn't matter. So it will help us to make this independent development of the agents, and supervisory agents help us to make the correct route and connect to other agents, and maybe even make a complicated task. What it means, complex process, complicated task. Let's imagine the situation that for one of the requests, I need to communicate with many different agents. Maybe 2 of them, even 3 of them, maybe 5 of them. And this is exactly where we see the powerful of multi-agents collaborations, because in that case, our supervisor agents can create a plan what we'll need to do and which agents we will need to invoke to get this information or proceed with this information, for example, collect some reports or data and so on. So I for sure execute the plan based on what capability we currently have in our multi-agent collaboration. And so this is what looks like, hey, we start with plan. What kind of the steps? Maybe under one step we have another couple of the steps. Make decisions what kind of agents need to call, and back to initial request to our initial user with the final result. You know, I don't like a lot of to talk something. I prefer to show, and I think it's one of my key feature, if I can say in that way. So I prefer to show something, demo. So let's go with the demo stuff. How it will looks like. Before we jump in exactly to AWS console, let me explain what the use case, what the scenario we will have. So I'm going to show you a mortgage assistant. And previously, before the multi-agent collaborations and that stuff, we should, for example, set up our call center, got a call from our customers, or maybe got emails, requests somehow, and proceed with every request individually based on what's our customer ask. Like, for example, what's the current existing mortgage I have, what the mortgage application is, maybe general questions, and so on. That is exactly what we will do currently in the Bedrock. I already deploy everything. Let me show you what we currently have. I'm currently in AWS console. and go into the builder tool area where we have knowledge base. Knowledge base for me, it's RAG system. That's what I told you just like a couple minutes ago, where I store information about mortgage, about what's my current applications, and so on. And as you can see, I already have 4 different agents. 3 of them, it's my sub-agents. And the last one, it's my supervisory agents, which control the road from initial request from the user. For supervisory agents, I selected Claude Sonnet 3.5. And in the bottom, we would see, here we go, this is my multi-agent collaborations configurations. If we go deeply, we will see that I have 3 different agents with specific configurations and so on. And now let's just test this agent in action. What will be if I ask some couple simple question? And it would be how it will be looks like in the console. You can create on top of that some web interface, whatever. And let's start with some super simple questions. What's my current balance like? What's my current mortgage balance? And you see from the right side for you, it's a trace. My supervisory agent decided that I need to call this agent. Let's ask something else. General questions about the mortgage. To explain me what's the difference between fixed rate and adjustable rate. And now my supervisor agents understood based on the request from the user, I need to call another agent which have access to knowledge base and store everything related to the current mortgage rate and how it looks like and so on. The last one I ask, not the last one, like almost the last one. So I ask another question, and it's called mortgage applications agents. For example, what kind of the document I need to bring to apply to new mortgage, and so on. And now let's see in action, what if I ask more complicated question? Which need to call 3 different agents and give me the final result. So I just ask, hey, give me what's my current balance. Please advise what I can do currently if I want to apply for $300 mortgage, how much I should to pay, and so on, so on. And you see, supervisory agents understood it's required to call 3 different agents, run it at the same time simultaneously. So we see it's called in parallel, and we got the result. Also, from the right side for you, we can go deeply and see the traceability. It's another biggest benefits of the Bedrock, where you can see why our supervisory agents made the decision to call this amount of the agents and what's the output we got it when the agents return with the result. So this is how multi-agent collaborations works in action. But still, you know, like based on my experience, sometimes it's so difficult to create new agents because it's required to set up functionality, open the API schema, make descriptions for every actions for every tool. For that reason, currently almost, I believe, most of you, I hope, heard about MCP, Model Context Protocol. It's a general communication protocol. You would be very surprised. It was released and published from Anthropic last year in November. And currently, it's still like so popular because it's standardized approach how we can develop the tools. And it stays so popular that it's currently one of the most fastest growing open source projects in generative AI, in Gen AI era. And ecosystem of MCP is so huge currently. You can find like almost everything what you want. AWS also already released a couple of the MCP servers. You know, when I done with my deck, so we had to upload it in last week, and exactly on that day when I uploaded this deck, AWS released a couple other MCP servers currently. For example, it's available for EKS, for ECS, for Lambda, like for many different services. But what's the powerful, why this like game changer with MCP? So why it stays so popular? Previously, again, when we need to make new functionality or extend the functionality, for example, for our agents, we should make individual development for different models. So we're responsible like for almost for everything. With MCP, we currently have, first of all, unified process. And we can add our, one time we develop MCP server and connect it to multiple agents without any, even to rewrite and make some adjustment and so on. And the biggest benefit of the MCP, it's self-discovery. So when we connect new MCP server to our host, we will see what the functionality is available. I already said a lot of time MCP, 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 and so on, but what's exactly under the hood? What's kind of the components? So first of all, from one side, we see its traditional way of agents when we create a custom API integrations, descriptions. From the right side, we see approach of MCP that we have MCP host, models, MCP clients. What's the core components of MCP in general? There are three main components. The first one is our MCP host. This is our environment where we exactly run our MCP clients and make the connections. So the third part of MCP, it would be MCP client and our MCP server. For me, MCP server here it's presented on three different another components. And this components, it's a tool what we can make some functionality, make a call, for example, or proceed with our JSON schema and whatever. Our resources, it can be, for example, can be my internal file system. For example, the content of a file, or maybe connections to databases and so on. And for sure, prompts. Prompts has very huge power, and this is how you can control what the model will reply, will respond to you based on your prompt and what you send it. Highly recommend to spend like a couple hours to go deeply a little bit on prompt engineering. So we understood currently that we have host, we have a client. You also should remember that for every client, we create only one connection to another MCP server. MCP servers can be local, what you run exactly in your local environment, or it can be remote. I would highlight and say, please be very careful because MCP is growing so fast and so many different servers currently available in the internet, but not all of them are secure. So please be aware of that, even if you run local MCP server. So if we're back to initial configurations of functionality of our agents, we can currently say, hey, inside of our agents, we can have MCP host with this capability of MCP client and connect it to multiple different servers. And it's a good time to, again, watch how it works. So I would not connect it to Bedrock currently. I want to show you just like maybe in actions what MCP can do for you. Just like today. So my demo will be based on Amazon QCLI. Amazon QCLI for me, it's just MCP host where I run my clients and make the connections to my, mostly all of them would be local MCP servers. So Amazon QCLI, it's terminal service. So for that reason, I already in my terminal. And let's call my QChat. QChat, it's open for us. It's interaction mode where we can do any stuff. And as you can see, I already have a couple of MCP servers connected to my queue. And the first one is Obsidian. Obsidian, it's just note-taking tool. I really like it. And this is where I store my to-do list, for example. Let's just ask what's my to-do list for today. Not today, it was on Sunday, honestly, but anyway, so what's my to-do list for Sunday? And it's understood I need to call separate tool from MCP, make a connections to my Obsidian server, and return, hey, I already done with multi-agent collaboration demo, and I still have two another demos. So if we call all tools what available currently in my MCP host, you see I have Kubernetes, and I have a ton of them related to AWS. What I can do with AWS MCP servers. So, for example, I prefer to write my infrastructure as code on Terraform. And just for demonstration, I downloaded one of not very secure GitHub repository. It's open source. What I currently do, and I say I trust all tools. Highly not recommend to do it on production. It's just for demo. So I trust all of the tools what I have inside in my MCP host. And I ask Amazon QCLI, can you please review all of my Terraform code in current directory? And what's currently happened? So based on my pretty big request to analyze Terraform code. It's just read what kind of files I have inside in my file system, understood that inside in MCP Terraform server, I have Chekhov as a tool. Chekhov, just in case if you don't know, is open source tool what you can use to analyze security of your Terraform code. Run it against of my Terraform models. And just in a second, we will get the results. Yeah, it's just for demo. It's not very secure code because, as you can see, I store in this GitHub repository. First of all, it's not encrypted S3 buckets, and it's hard-coded some credentials just without any encryptions and so on. But anyway, it's just for demonstration and show you how easily and quickly I can connect additional MCP server like from AWS, and analyze my Terraform code in action. You remember I also show you that we have Kubernetes. So what I can do with Kubernetes MCP server? Currently, I have some problem with one of my pod. It's restart constantly, it's crash loopback. As you can see, it's already restarted 30 times. Again, let's go to my Amazon queue, and let's try to ask help to troubleshoot and fix the problem. So what I want to show you here, when we connect new MCP server, MCP host will do self-discovery of the functionality, what is capable from my MCP servers, like for example, from Kubernetes, I'm able to describe the pod, get the logs, restart, create a new one, and whatever. And first of all, it's understood what's the core problem of my configurations in my manifest. I made a mistake that I run container in one port, but for liveness prop, I use another port. It's model and host understood that's what the problem is, understood how to solve it, and create even of new pod just in a few seconds, as you saw in this demo. So it said, hey, I created a new pod, and the root cause was related to misconfigurations of liveness prop and what I have inside in my manifest in my container. Just to prove it, here we go. This is manifest. You see 9/11, and for 80, it's for liveness prop. And currently, let's quit Amazon Q CLI and just double check that I have my pods in a running state. Here we go, everything looks good. This is how we easily and quickly can extend the functionality of our generative GenAI agents to add additional MCP, even in Bedrock. But what I would love to start something maybe simple and in my local environment, for example, in my local machines, to create my first agent. Because in Bedrock, it's fully managed service. But what if I want to maybe start my journey in generative AI agents, just like maybe from simple stuff? For that reason, just 2 weeks ago, AWS released new open source framework, which is called Strength Agents. And Strength Agents, it's exactly try to solve this problem that give you capability and functionality, how you can start easy on your local environment, and for example, in the future, go into the Bedrock, just in case. So what Strength Agents is? So first of all, it have native integrations with MCP. We already have many integrated tools, but what's the core stuff? Again, what's the building blocks of Strength Agents? Again, super simplified schema. So we have, again, 3 main components. The first one is our model. The third one is our tools. And the last one is prompt. Prompt would be everywhere. In a model, what we can do, for sure, we will highly recommend to use Bedrock, but even of that, if you have your local Ollama, for example, you can connect in Strength Agents to your Ollama system. In the tools, you see, I said like we have pre-built tools. Currently, it's 20 plus pre-built tools. We also have native connectivity to MCP, or even you can create your own custom tool. And based on that configurations of 3 components, we will go to agentic loop when our initial user asks some question related, for example, I don't know, again, HR policy, or give some reports, or proceed some documents and whatever, or planning my vacations, or planning my schedule next meetings, or Hamburg Summit in next year. and we send to the model the current request, maybe need to call some tools, maybe we need again to ask the model what should be the next step, and so on. How you can start to create your first strength agents. It would be super easy because we try to simplify its process as much as we can. So you see on this code, first of all, I define the model. The third one, system prompt, and connect some tools. Some of them, it's pre-built tools. For example, current time. You remember, models doesn't know anything about external world, like even what the current time is. And you can create your own custom tools. Custom tools, it can be written exactly in the same file with decorator in the Python. It can be just specifications in separate file, whatever. So you can do how you prefer and how you want to add additional functionality in your strength agents. I think one of the biggest benefits of strength agents, again, it's a native integrations with MCP. So you can just connect MCP to your strength agents on a different way. So the first one, it would be, I think, one of the easiest. It's standard input-output, where we communicate it through the command line, maybe through the HTTP or server send event. So whatever you prefer, we give you capability of communications and connections to MCP, how you prefer. Also, related to our initial big topic, it's multi-agent. In strength agents, you have functionality to apply many different patterns of multi-agents collaborations. Not only the single one, what I showed you previously when I have supervisor agents. It's the first one, agents as a tool, and then some multiple different agents inside. So you can do swarm, you can do graph, for example, to create a graph of different agents and say, hey, if you need to communicate about HR, it's your path of all questions related to HR something. Or maybe some standard workflow if you have some standardized business process and maybe you prefer to create a pattern of multi-agent collaborations through the workflow. Okay. Sounds good. So we can start it from hello world and extend almost to, I don't know, whatever we prefer. But how I can deploy these strength agents? It's another point what we would love to achieve, because we totally understand that you as a developer, you truly love to do something simple, like from the local environment, from my laptop, for example, and then maybe extend, go into the productions for sure, deploying something remotely. For that reason, in strength agents, what you can do, you can run everything locally, start your creating first agents, just like Hello World, or maybe Schedule Assistant, or maybe AWS Assistant, and whatever. And after that, as soon as you understand, okay, I'm ready to move to production, I want to make the separations between my prompt and the backend environment, like my agent, my tools, everything what I needed, like maybe a RAG system, maybe something else. Where you can deploy almost everywhere. EC2 instances, Fargate, Lambda function. So you can deploy strength agents like anywhere. Whatever you prefer, what's your would be best options, you can do it. Even of that, we can move on the next step. We can make the separations between our agents backend environment and another tools. Maybe it would be separate tools what we want to create shared for multiple agents for different reasons. Just like, for example, maybe some of them have capability to connect to our RAG system, to our knowledge base, maybe to our databases and whatever. Or even maybe you need to get some local data. What I mean maybe you create some code assistant or maybe whatever. You need to read some local file content. So for that reason, we need to have capability of local tools. You can do it, and also on that way to connect to some local tools, for example, file, maybe your schedule in your Outlook or whatever, you can do it. And again, last demo. I hope you're still with me. So what the last demo would be? All of my demos, what I show you today, it's code samples inside an AWS GitHub repository. This one, it's also. Why? Because I want to make sure that you would be able to repeat at home by yourself. And this specific case, what we are going to do. So it would be my AWS assistant based on the strength agents. I test it locally. I mean, like I deploy everything on my local machine. It's my laptop. And what the functionality of these agents would be. This is the architecture diagram, what's the kind of the functionality I have, and I'm going to test only 3 agents inside in these multi-agent collaborations. So I have one single point of entrance to ask questions. It's my AWS Assistant agent. Inside of that, I have cost analysis agent, and another one is related to create some visualization, like a graph. And this is my Visual Studio with README. Let's go inside in main py file. Currently, strategy agents only support Python. We already have PR to support JavaScript, so on. We are working on that, so in the future. This is my system prompt, how supervisor agents should route different requests and how to execute and what's the procedure in general for my system agent. For AWS cost analysis, as you can see, I connected MCP client to my MCP server, what provided this functionality of cost analysis. Back into my terminal, if I just run this agent locally and ask the questions, can you please give me the information how I spent money inside in my AWS account in last month, and can you please make some graph of that? So it's connected to MCP server. Through the MCP server connected using my AWS config, got all information related how I spent and what's the current number I have. Even of that, created a graph in HTML. Give me not so fancy, but just for demonstration, I believe you understand how you can improve and make it more interesting in your case. Double check that, yes, this HTML file existed locally. And at the end, just show me, hey, this is how you spent your money. Just like, for example, in EC2 instances, I spent around $5 in last month. For OpenSearch, I spent $15, something like that. And give all of this information based on my one request with multi-agent collaborations inside and my strength agents. Cost analysis and visualizations framework. I understand it's a lot. I totally understand this can be a lot. So what we discuss, just like super quickly to summarize. We reviewed multi-agent collaborations inside in the Bedrock, how you can create your complex task. You can try by yourself to create your own first multi-agents or deployed already something from the samples. We review of MCP, what's foundations under MCP, what kind of the capability MCP can give us to see that it's very easy to extend the functionality of your current agents, generative AI agents. And even that we finish with strength agents, it's our super fresh, super new open source framework where you can start to create your first generative AI agents just locally and start your journey in this area. So also today we announced about a very important announcement, Sovereignty Cloud. So please ask outside. And I want to say thank you very much to be with me. And if you like this content, please don't forget to evaluate my session in app application. Thank you very much. And I would be here till the whole day.